everyone. In this video, we're going to be solving a very exponential equation with imaginary numbers and an irrational number, or should I say transcendental number, or should I say Euler's number. Anyways, you got the whole thing, I to the z equals ei. Remember, we've done a problem a while ago. If I can find it, I'll link it down here. But that problem was about an exponent that doubles. And the problem was I to the z equals 2z, right? Or something like that. Well, in this case, we kind of have, or was it 2i? I think it was 2i, because I don't think the exponent doubles here, just doubles the z, right? So something like this. So the exponent doubles the I. Makes sense? So what should we call this? An exponent that multiplies I by e, or should I say an exponent that e-tuples. Okay, you know how we have the double, triple, quadruple? This is e-tuple. Anyways, this is the problem we have, and how do we solve it? I think there are two approaches, the main approaches here, and if you have anything else, let us know. One way to do this, can we solve this problem replacing z with a plus bi? Let's give it a try first. It's not one of the methods, by the way. If you do that, you kind of need to write this in complex exponential form. How do you do that? You can write it as e to the power a plus bi multiplied by ln I. And this one is ei. I mean, you can divide by this, or just write the I as e to the power I pi over 2. But I'm going to add multiples of 2 pi. Okay, awesome. We can go ahead and put e to the 1, and then add the exponents and natural log. By the way, I'm going to replace ln I with something. Everything is constant, so we should be able to solve this. And then from here, this gives us ln I. What's ln I? ln I is ln 1, which is 0, plus I times pi over 2. And if you want, you can add 2 pi k, because ln of a complex number is multi-valued. All right, this is 0, forget about it. And now we're going to go ahead and divide both sides by ln I. So a plus bi is going to be 1 plus I times pi over 2 plus 2 pi n over I times pi over 2 plus 2 pi k. Interesting, right? And we can multiply the top and the bottom by negative I to get rid of I, because this becomes 1. And here, when you multiply by negative I, you need to distribute. Let's do it. When you distribute, you're going to get negative I, and this is going to be 1 again. So like this. And at the bottom, you're going to have pi over 2 plus 2 pi k. And in order to be able to write this in standard form, you can write it as this. Minus I times, wait a minute, it's not minus 1 times. Oh, I can probably write it as 1 over. Okay, here we go. I can write it like this, right? That's what it is, isn't it? Okay, so now what happens? This is A, and that's our B, along with the negative sign. Of course, exclude the I. Make sense? So from here, we can solve for AB and then find the Z value. But it's not the best way to do it, don't you think? So let's go ahead and take a look at it from another perspective. All right. So for my, let's call that one first method, even though it wasn't intended. Let's go ahead and go with the second one. So I can be written as e to the power I pi over 2. This time I'm not going to use the addition. I don't think that's necessary. And that probably wasn't necessary here either. But anyways, you can decide. Right-hand side is going to be e times e to the power I pi over 2 plus 2 pi k. I do need it here though, because we need to consider all possible values of I, all possible representations of I. This gives me e to the power I z pi over 2 equals e to the power 1 plus I times pi over 2 plus 2 pi k. Okay? And then the same idea. I think we're going to end up with something similar. The only difference I think is going to be that we're not going to have any integer at the bottom. So in this case, I use the k differently. So I think k is going to be 0. And the reason behind that is I don't think we need to add another k here, but I could be wrong. Anyways, correct me if I'm wrong. I know there's a lot of people on my channel who are very knowledgeable about complex numbers. They know more than me. I've been taking a complex analysis course, just my knowledge from high school and trying to read up on that a little bit, okay? And you might be saying like, why did you start a channel all about complex numbers if you haven't even taken complex analysis? Well, I wanted to take it. Maybe I'll take it one day. Who knows? Maybe Monday. So this is our expression, and obviously the same idea is going to apply. And when you write the solution, it's going to be pretty much similar to this, except you're not going to have the bottom part. I'm thinking, but I could be wrong again. And then let's just go ahead and do it. We could just multiply by negative I first. I want to do that first, okay? When you multiply by negative I, it's going to become z pi over 2. Negative I is going to make this 1, and we're going to get this. Great. That's the real part, by the way. And then divide by pi over 2, we're going to get this. This divided by pi over 2 minus I times 2 over pi. So the only difference is, yes, we are dividing by something simpler in this case. Does this work? That's for you to decide. But here we can simplify the pi's. See? And that becomes 1/2, so I can kind of multiply the top and the bottom by 2. Cancels out. Distribute and forget about the pi. So z becomes 4k plus 1 minus I times 2 over pi. You do need the imaginary part. Imagine you didn't have this part, then you would just have 4k plus 1. But if you think about it, what would happen if you replace z with 4k plus 1? I to the power 4k plus 1, if k is an integer, it's always going to be I. As you know, it's not going to have the e component. And that e should be coming from here, if I didn't make any mistakes. Okay, what's a third way to approach this problem? I think there's a third method, which is very similar. I know it's going to be like, this is boring, right? But I'll still talk about it. Okay. The third method basically involves dividing both sides by I and getting rid of the extra I here. I to the power z minus 1 equals e. And then you'll do the exact same thing and come up with the answer. And do I have the solution from Wolfram Alpha? Uh-oh. When I asked this question to Wolfram Alpha, that's what I got. I'm like, come on, Wolfram Alpha. You can do better than this. What does the error function have to do with this? EI does not mean the, was it? No, exponential integral. Sorry, not the error function. It's the ERR, right? Or ERFI, something like that. Anyways, this is the exponential integral. What does this have to do with that? No, this is the correct solution with a better prompt. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.